first and foremost, obviously, thanks to everyone for joining the latest episode of Golang Live. Yeah, my name's Shaun, and I'm one of the founders over here at Amicus. We're a niche recruitment supplier of Golang, Python, and JavaScript professionals, but pretty ingrained in the community. So we do a lot of work in like webinars, meetups, etc. So tonight I'm joined by Robert. Robert's going to give us a talk into simple Go event-driven architecture and give us an introduction into Watermill. So I'll hand it over to Robert in a second, but just so everyone's aware, this is obviously recorded and it's all quite an interactive session. So if there's questions throughout, feel free to ask, and at the end during the webinar, Robert's sort of presenting and there's sort of a brief break, I'll ask questions there and then etc. So without further ado, I'll hand over to Robert, and yeah, feel free to enjoy.
Well, thank you for the introduction. So let me share the screen. Okay, I hope that it works.
Yeah, we're all good. I can see it. I think we can see it, so it's perfect.
Just arrange Windows a bit. Cool. So thank you for the introduction. And yeah, I'm Robert, and well, during the day, I'm working as a principal engineer in Karhoo, but I have also some strange hobbies, so I like to code after work. And yeah, I'm also trying to do some things that may make Go community a bit better place, I would say. So one of the things is blogging at tradeoffs.tech. So hopefully some of you already know that blog. I'm also a co-author of Go with the Domain ebook. You can find me on Twitter and on the GitHub with Nick Rob Laszczack. And yeah, I'm also one of the authors of Watermill, and about which I will talk today. And some story at the beginning, actually, how Watermill was created. So in the company where I worked a couple years ago, we had pretty typical challenge to solve. So I think that we can look on any application like Twitter, for example. So in this application, you usually have some ability, so users are able to add some content, and you are usually storing this content in some transactional database like MySQL, Postgres, or whatever. But it's not unusual to have some use cases when it's more optimal to store it in a different database. But by the way, this is named polyglot persistence, when you are storing the same data into databases. And in theory, it looks nice. So you have some data in MySQL, you have some data in Postgres, but this approach has some challenges. And what changes? So the first changes is that if this part that I marked on the slide is synchronous, it can be just slow. So let's imagine a scenario that we have Twitter-like website, and some person is adding some content, and this person is followed by 1,000 followers or even more. And so if we'll have some read model in Elasticsearch which will be responsible for personalized wall, so you will need to save this tweet to 1,000 words, for example, or even if this person will have more followers, so the complexity is rising. And it will be probably not the best experience if adding a tweet will take 30 seconds or even more. And another problem that you can have in that kind of architecture is that what if, for example, this part will fail? So how you should handle that? So you already committed, for example, changes to this MySQL database, but this changes was not stored here. And in this case, you will have some inconsistencies in your data. So it's, in general, not the best scenario. And yeah, the typical solution for such challenges is using event-driven application as some kind of event broker or PubSub. So in the team, when I work with, some of the team already had some experience with Kafka. So yeah, we decided that Kafka works pretty well for what we like to do. We had also some experience with that. Cool, let's go with that. But well, it didn't take a lot of time to understand that as every solution for some problems, it can give you some other problems instead. So that's why actually pretty important to ensure that if you are solving some problem, you are sure that you are solving the right problem. Because if you are not solving the right problem, you will end up with two problems. So it even works. Yeah? Fortunately, in our case, we're solving the right problem. But yeah, as I said earlier, so this flow worked that instead of in cost of saving this problem was having different problem. And what problem? So the problem was actually pretty simple, and we figured out that, well, building event-driven applications is not that easy, especially in Go, and the tooling was a bit missing. And I started actually to wonder that, if, for example, you are building HTTP server, you are not thinking too much about TCP or about network protocols or multiple network layers. You are just implementing endpoints, and you don't care too much about how it's working under the hood. And I started actually to wonder how we can do it in Go to make building event-driven application as easy as is done for HTTP. And yeah, this is how Watermill was created. And I forgot actually about that one. So this actually some usual issues that you have during building event-driven applications. So you need to care about consumer groups, partitioning, message ordering, at least once deliver, message acknowledge, negative acknowledge, poison kills. At the end, you need to also sure that you are not losing any message. So this is what we would like to simplify with Watermill. And yeah, so far, I can say that we have almost 4,000 stars on the GitHub. Hopefully after today, it will be 4,000, so I believe in you. Currently, project was built by more than 35 contributors across multiple repositories. We are officially supporting 10 different PubSub or message broker implementations. And what is the most important? We have logo. So we have logo with Gopher vomiting to Kubernetes logo. Don't ask me why, but it's some kind of artist vision. We have that, so that's cool. And at the beginning, when we started to think how Watermill should build, so the idea was that it shouldn't be a framework. So if you are coming to Go from some different technologies, so you probably have some experience already with that. Some companies started with some framework and it was one-way ticket. I mean, if it was not separated properly, and from my experience, it's usually not separated properly, it's almost impossible to get rid of that framework. I think that this is pretty important. That and this is usually working that way in Go. If you are not going with an HTTP framework, but rather with a library, so you have much more flexibility that, okay, for example, you didn't like Watermill after 2 years, you can switch to anything else. So I think that's pretty important, and it's also in line with some kind of Go philosophy, how usually people are using that. And so that's why Watermill is a library. And as I said, so currently we are supporting 10 different PubSub implementations, including Go channels, Kafka, BoltDB, Firestore, Postgres, MySQL, Google PubSub, NATS, or RabbitMQ. So pretty a lot, and it's still open list. So it's not baked in the code. You can easily implement your own implementation based on anything you would like to have. That's pretty cool. And yeah, you might ask actually how it's everything built and how it's everything connected. So at the very beginning, the important thing that we took into consideration was Unix philosophy. So this is something, well, already pretty old because it's from 1978. So probably most of us are younger than this philosophy. And what it does say to us. So it says to us to write programs that do one thing and do it well, write programs to work together, and write programs to handle, well, in our case, message, because that is an universal interface. So I think even if it's pretty old, it's still 100% valid. And fun fact about authors of Unix philosophy. So yeah, authors of Unix philosophy is this guy, and probably you should know this guy. And you should know this guy because this guy was also actually part of kind of team creating Golang, and this is Ken Thompson. So, I think it's pretty interesting if you think about Unix philosophy and Golang design, that it's pretty in line to this philosophy. And when I see some philosophies like this, I am a bit nostalgic sometimes. I mean, it's some old programming philosophy invented by people pretty long time ago, and it's still super valid. So this is actually pretty interesting, but I think it's also pretty sad sometimes, because if I were asking a lot of people about Unix philosophy, they didn't hear about that. So that's kind of sad that, some solution for our problem exists for pretty long, and, people kind of forgot that. But yeah, anyway, this is how it is. But yeah, I'm always encouraging people to look for some old school theories, because yeah, you can find something interesting. Okay, let's go back to Watermill. So the first and most important type, I think, in Watermill is a message. So this is, if we'll compare it to HTTP, it's something similar to HTTP request. So in this case, we have some UID of the message to be able to identify that. We have metadata, so it's kind of like headers in HTTP request, and we have payload that is kind of like body in HTTP request. And this is the type by which we are communicating, and I will show later an example. The second component is publisher and the subscriber interface. So this is the interface that you need to implement if you are adding a new PubSub implementation. So every PubSub that we currently have are implementing this interface, and it's pretty straightforward interface. So publisher gives you ability to publish a message to some topic. So topic is, I will maybe compare it to URL in HTTP. Like, I mean, if you are probably it's better to understand it with a subscriber. So with publisher, you can publish some message, and with subscriber, you can get this message from provided topic from using a channel. So that's pretty straightforward, I think. To join these two parts, you're using something that is named handler function. So if you think about any event-driven application, so idea is that you're receiving some signal, message, or whatever, and you are returning some message or nothing, or error if something went wrong. And if you think about event-driven applications, so it's just composed from list of such functions. Yeah, we are also providing out of the box some middlewares. This is pretty similar, as you can see, for HTTP, and I think it is pretty good because it's making the entry point to Watermill much smaller. So the idea of middlewares is exactly the same how it's for HTTP and for gRPC actually, but in gRPC it just have a different name. And everything is connected by router component. So router component is responsible for getting this message from subscriber, calling subscriber, and calling the right handler. So you can see that we have publisher at the beginning, and it can be publisher from Watermill, it can be a publisher from any different language, it doesn't matter. And we have some queue, broker, or topic, and subscriber is subscribing to this queue, broker, or topic. And yeah, router is getting this message, and through middlewares it's kind of handing calling handler. And yeah, if everything went fine, so we can publish some messages, and yeah, at the bottom we can have another handler. And when you are building such library, so it's essential to have good testing for that. I mean, in our case in Karhoo, so it's processing super important data, and we need to be sure that we didn't lose any message on, and it's just readable, and we trust that it's working. Because of that, we implemented pretty a lot of automated tests that are also allowing us to just go fast. Yeah, so ensure that we can do updates of PubSub or any Watermill component, and we are sure that nothing is broken. So the first important kind of type of tests are PubSub tests. So these PubSub tests are tests that every PubSub needs to pass. So the idea is that if you're implementing a new PubSub implementation, you should almost not write any tests. You should use the tests that are already working. And it's pretty simple because you have the same interface for everything. The only difference that you have is some characteristics. So if you are already familiar with event-driven terms, so for example, some implementations are supporting consumer groups, exactly once delivery, ordering, or persistent. Yeah, so this is some characteristics under the hood, but it doesn't change a lot in that case. And yeah, you're just calling test pops up, and yeah, magic is going under the hood. So I think it's making this process of implementing a new pops up much faster. And fun fact, how these tests are working nice is that some of the pops ups we implemented actually without using it on the production, because we didn't have access to any production system that used, for example, Google Cloud pops up. And yeah, okay, so we just use this test and we hope that it will work. And actually, after some time, we had the chance to use some in the production, and yeah, it was working. So I think that it's nicely showing the power of this tests. And yeah, we have also stress tests, and stress test idea is super simple. So let's just get all these tests that I mentioned earlier, and they have some, I would say, strange cases like disconnected from server, closing server in some strange cases. And we need to be sure that we are not losing any message. So the idea is, okay, let's just run this test 10 times in parallel. And well, it should be still super stable. So that is adding a bit even more, how to name that, ensuring us that everything is working as expected. Yeah, so also remember that when I was running this test at the totally beginning, it was like I left my laptop for an entire night for running this test, and I'm pretty sure that my laptop already hates me for that. But yeah, laptop survived, and yeah, every message was delivered, and yeah, test was just passing for an entire night. So that's pretty good. And the last, not least, about Watermill is how fast is Watermill. So it's pretty important thing for some of you probably that, okay, you may be working on the systems when it should just work fast. So that's why we created an official benchmark. And these are the results. By the way, you can clone it from the repository and run by yourself and try to improve. Maybe it can be improved a bit. And yeah, one important disclaimer. So we did that test on one instance within one Go process with Docker Compose. So why one instance? So one instance to just avoid situation that we are spanning 1,000 cluster of Kafkas, and we are measuring that because it will be, well, probably can go check what are the cloud providers' limits for spanning VMs and how much money we have, but well, probably it will not say a lot. So that's why we were testing it from one instance. And for example, Kafka. With Kafka, we can publish 70,000 messages per second. And what is important? So it's synchronous publish. I mean, it doesn't mean that it was saved to some internal buffer and it will be stored later. So the design decision in our case was that, okay, it's published to the broker and it will not disappear. And for Subscribe, the situation is pretty similar. I mean, this is Subscribe with acknowledge of the message. So with ensuring that it was consumed and it was sent to the broker. So this is pretty important because without that, it will be probably faster. But yeah, our decision was that it's more important to have consistency. As I remember, you can configure it from configurations we would like, but this is the default behavior. To compare, MySQL pops up, and you may ask, actually, MySQL pops up, what the hell? And yeah, the idea is that in some use cases, we'd like to avoid two-phase commits. So let's imagine the scenario that you would like to save something to a relational database and publish some message, and you would like to be sure that it's always made in the transaction. So if you are doing it with Kafka, it's a bit problematic because if you save the transaction earlier, sending of message may fail. And if you send the message and later try to commit transaction, the transaction can fail. So in this case, you can publish the message directly to MySQL and later stream it to your PubSub. And in this case, you are sure because the message is published to MySQL admin in the same transaction, so it can be sent both or fail. So that's pretty cool. But it has some trade-offs, of course. So the trade-off is that, okay, you can publish at most 7,000 messages per second. So of course you can probably tweak that, but yeah, it was a simple benchmark. And you can subscribe for 143 messages per second. That it doesn't sound probably like super a lot, but if you are good in calculating in mind, so it's almost or even more than 12 million messages per day. So I think that it's still a pretty decent number. And yeah, MQP, RabbitMQ implementation, so you can publish up to 2,400 messages and subscribe to up to 10,000 messages. So that's pretty cool. All right, so I think that part that a lot of you might be waiting for. Yeah, the first rule of live coding. Do you know the first rule of live coding? The first rule of live coding is don't do live coding. So we'll do live coding because it's always a good idea. So let's see what will not work. So okay, I have my terminal, I have my Golang, and yeah, I have my application. So I prepared some application that, well, it's pretty typical application. So we have some main, we have some router, and we have book endpoint. So the idea is that, let's imagine that it's very simple booking application. And let me show you how does it work. So the idea is that you can post booking to the endpoint. And well, it's not super stable. Sometimes it's working, sometimes it's not working. Sometimes it's working slowly, and it's even not working. And as you can see here, we have a lot of garbage here. That's good, because that's kind of application that event-driven architecture can help with. So let's see what is going on here. Okay, we have some simple main function here, nothing interesting, some signals handling, running HTTP, blah, blah, nothing interesting. Let's look on our handler. Okay, so we have our booking handler, we're unmarshalling request, payments provider. What can go wrong? Okay, and as we can see, our payments provider is not the most stable. Well, it happens. Maybe some of you already have experience. So this is how sometimes you are working with some external parties that they sometimes are working, sometimes a bit less, sometimes they're working slower. Well, it happens, but sometimes, unfortunately, we cannot do too much about that because our boss likes their boss or whatever. It just happens, yeah? But okay, well, what we can do, we can go cry and leave the job. But yeah, I think that we can also try to use Watermill and just improve that situation. And, okay, we can probably also remove that, but probably we'll also need to change the job. All right, so what is my idea? So my idea is, so let's, instead of taking payment asynchronously here, let's try to emit an event that will name room booked. And let's try to listen to this event with Watermill, and let's try to take payment in the background because, okay, maybe it doesn't need to be really synchronous and, you know, giving not nice user experience to the user. Okay, so let's start with, okay, we'll actually drop that, but instead of our payments provider, we'd like to have publisher. And we need to have also our event. So our event will be room booked. So I already prepared some snippets to just not lose too much time on writing non-interesting things. And we'll marshal this event by JSON because it's pretty simple. You could use protobuf, JSON, or whatever, up to you. In Watermill, it's just slice of bytes at the end. And room booked. Yes. So we have our room booked event. We need to marshal that. Okay, don't do it in home, but okay, we'll be just, I mean, don't panic like that in home, but okay, that just for simplification, let's do that. And okay, we have our payload, and let's use our publisher. Publisher publish. If you remember from the slides, we need to provide topic. So let's name topic bookings, and we need to have our message. New message. So we need to have UID. New string, and we need to have our payload. Cool. Okay, and panic again. Okay, we have our publisher. So what we need to do, so it's injecting the publisher. By the way, I'm not sure if you know this method of injecting things to HTTP handlers. If you don't, it's pretty useful. I will show you how does it look, how it does look here. Yeah, so we have our room bookings handler, and we are just providing this function in that way to our router. So that's cool because we can inject stuff here. So we need to have our publisher, and yeah, I also took a snippet from documentation to not lose too much time. But yeah, no worries, you can just find this in the documentation. There is totally nothing custom here. So we are providing address to brokers. We are providing unmarshallr, that is unmarshallr for Kafka messages. If you'd like to do something super custom. And yeah, so for now we need to have our publisher, and let's inject it here. Okay, so this is the idea. We have our room booking handler, we have our publisher, and we have it here. Okay, so let's see if it's compiling. By the way, I'm using some tool which is named Reflex. I'm not sure if you know that tool, but it's pretty good tool because it can with some configuration, it can automatically rebuild your Go project on any change. Fortunately, Go is compiling pretty fast, so we can do that. At the end of the presentation, I will give you a link to the article when we're describing it on the blog. So I think it may be pretty useful for you, as if when you are developing such application, you can save a lot of time of not running the terminal rebuild every time. And you will also instantly see that, okay, if you do not compile, okay, we can see that it's not compiling. But okay, would like this to compile. We have our handler. Okay, so let's try to call our endpoint. Okay, it's stable and it's fast. That's good. And we'll use also one tool to check if our message is published. So it's named Mill. So Mill is part of Watermill, as you can guess. And now after, okay, and you can see that we are with Kafka, with Mill using Kafka with broker like this, topic bookings, and we are consuming messages. And yeah, messages are here. So that's a good sign. And now we are missing the second part, so the part where we are consuming this event and calling payments provider. How it was named? It was the payments handler. So I have also boilerplate for that. And yeah, as you remember from the presentation, so we are accepting message and we can return some messages. And in that case, we would like to inject payment provider. Okay, and yeah, so let's write that. So at the beginning, we need to unmarshal our event. Sorry, it's not payment taken, it's room booked. Room booked, JSON unmarshal, message payload, and room booked. And there is at least one thing that we did better in Watermill than in standard library, so you can return error from handler. So you will never forget to do return in your handler. So that's pretty good. And yeah, if this will return error, so it depends on the PubSub that you are using. But in Kafka, the message will be redelivered in that case. So this is the default behavior for Kafka. And okay, so we unmarshalled that. So it should be able to call our payment provider and room book, well, not like this. Price. So we are taking payment for price provided in the event. By the way, in that case, maybe we would like to actually not return error, but log that. Print. It will be good probably to do it like this, because yeah, as I said, so this message will be spinning, and okay, if JSON is invalid, so probably it will be spinning forever. So it will be a bit better. Okay, okay, some ugly logging also. Don't do it in home that way. Okay, so we have our error. So if payment provider will fail, so in that case, we would like to actually try again. So this is the expected behavior that, okay, we'll return error from that handler. So this message will be redelivered in some interval, and we will take payment again. And okay, if everything was fine, we can return nil to not emit message and return no error as well. But I think that we would like to also maybe emit some event. Message pointer to it's slice of pointer to messages and message. Right. And okay, we need to have event for that. So let's name this event payment taken, and let's marshal it to JSON. We have our payload. Good. So in theory, it should be compiling. It's compiling, but we are missing one thing. So this handler is not used yet. So we need to start to subscribe to that. So let's uncomment our subscribe. And hopefully you remember from the presentation that the magic glue in Watermill is router. And yeah, router is just taking configuration, Watermill logger. That is interface, by the way, so you can put any logger there. And the router would like to know to add handler that will name bookings. We'll subscribe to booking. Sorry, handler name will be payments. It doesn't matter actually how this handler is named, so it's just for identification and logging. Subscriber, so we have our subscriber here. Published topic. So event that we are publishing is payment taken. So let's name it payments. And handler publisher. Publisher is Kafka, and handler function. So handler function is that struct that is named payments handler. Let's move it here. Okay. Okay, and we don't need to actually inject payments provider because it's struct, not interface, so it will just create a default value. So that's simple, and in that case, we are using dot handler. Okay, and the last thing that we need to do about router, it's running this router. So all right, so I guess that it have a chance to work. Okay, so we see that we have some Watermill logging logs, and let's call our endpoint. Okay, and then as you can see, payment is taken again, so it seems to work. Probably it will take some time because, okay, sometimes payments is taking a bit more time. Okay, we can see that we had error, but after that, the message was delivered and payment was taken. So that's pretty cool. And I think that, sometimes it's maybe good to add some nice features. So let's add some nice feature to our application. So router, add handler. So what will be the feature? The feature, I think that it would be cool if, okay, you are going to the hotel, you are paying for this hotel, and I don't know, some beer is ordered to your room after. So let's implement that. So let's name this handler beer order. Would like to stop. So as I said, so would like to send this order after payment is taken, because, okay, it doesn't make sense to get it to the room that was not paid yet. Actually, we'll use no publisher handler. So this is the handler that just takes a subscriber and doesn't publish anything. So we have our subscriber and we have our function. So in this case, also the function is a bit simpler. And yeah, so let's unmarshal our payment taken. Payment taken, error. And let's put anything simple now, like please order beer to the room. Okay, pretty straightforward, and return new as everything went fine. So yeah, let's see if it's working. Let's call our endpoint. Let's wait for the payments. And yeah, cool, it's working. Please order beer to the room 153. And I think that it's nicely showing that, okay, maybe it's actually, okay, not super a lot of boilerplate to create at the beginning, but yeah, after you have all that, I think a new handler is super, super simple. And what is also pretty good about this design is that I think it's one of advantages of ORMs that in theory they are allowing you to easily change database. It's maybe not always true, but yeah, in case of Watermill, it's actually pretty straightforward to change message broker or PubSub. And I will try to do some challenge. So, okay, I think that this live coding is doing pretty well, so we can try to do that. Maybe I will succeed. So my challenge is, can I actually change Kafka to Google Cloud PubSub within 1 minute? Do you think that I can do that? Let's see. I hope that I did that. And let's see if it's still working. By the way, it's just accident that I have Google Cloud PubSub and Kafka running in my Docker. But yeah, I'm just running everything on the Docker locally. And yeah, let's see if it will work. Oh, nice, it's working. Let's see if some message is appearing here. Okay, no message is appearing here. So let's check if we'll use our emulator and Google Cloud PubSub console, it will work. It didn't work, as always. Topic bookings. Okay, that's interesting. Yeah, remember the first rule of live coding. Emulator host new Google Cloud console project test and topic bookings. That's bad. Maybe something didn't work. Oh. Okay. Problem with coding, but at least it's working here. But that's interesting. Probably it's something not right here. Let's change payments. Typo. Yeah, I know. The address is wrong, probably. Okay, so you need to trust me as this is not working, but yeah, as you can see, the application is still working as expected. I think it will be probably some problem with Mio. Just double check. I think it should flag debug. Yeah. Let's check on bookings. Okay, strange. Maybe. Okay. Oh no, I missed that. I missed project here. Project ID. This. Okay, it will work now. Oh, you see, I didn't lie. Okay, so that's yeah, I think that's it for the live coding. Let me double check if I did cover everything. Yeah, so I think that's so far it's all for the live coding. And yeah, it was pretty successful with not counting one thing.
Robert, there's a couple of questions just from the audience. Am I okay to just after this? Yeah. So there's one saying, what are the benefits compared with the Go Library, Confluent, Kafka do offer?
So the idea is that we are providing a bit higher interface. I mean, with Confluent Kafka, it's providing a bit lower level interface. And actually, I forgot to mention one important thing. So that's good that you asked. So yeah, as I said, so the one thing is that it's just a bit more abstract. So implementation of when you have prepared configuration, you're just implementing one function. So that's good. And there's one important thing that you probably noticed that, okay, there's a lot of JSON and Marshall, on publish or whatever. It's a lot of boilerplate. And actually, so I don't have probably enough time today to show that, but we have also something that is named CQRS component. And the idea of CQRS component is that it's even a higher level, and it's getting rid of all JSON and Marshall. The idea is that we are just implementing handler like please give me this event. So for example, we are providing this type, and it's doing all the magic under the hood. We are also working on the newer version that will be using generic, so it will make the interface even simpler. But so far we have this CQRS implementation that is getting rid of all this JSON Marshall. So at the end, what you are doing in handler is just okay, so we don't need to do unmarshal. We don't need to marshal anything. It's just working out of the box. So that's the two biggest advantages, I would say. And yeah, the third one is it's probably not also super often needed, but I've seen it at least once in my life that, okay, team was changing the message broker. So it's also easier to do when it's just operation like this.
Perfect. There's just a couple of others. What is the retry policy in use?
So the default retry policy is actually what is supported out of the box by message broker. So if it's provided by configuration, so as I remember, it's in the Google Cloud PubSub client. Yeah, I think it was somewhere in probably subscribe config. So you can do it through subscriber config, but you can have also a second option. So in router, you can add middleware. And you have retry, yeah, and you have retry middleware that you can configure all the options that you need to have. So it depends what kind. So short answer is it depends what kind of message broker or PubSub you're using. If it's if it have good support of retries, you can do that. If not, you can use middleware and it can do it for you.
Perfect. And the final question, what would be the way of publishing to multiple topics in a handler?
So short answer is it's not possible. I mean, the issue is that most of the brokers are not supporting that. And yeah, I think that it was some broker that in theory does support, but in most cases, it's not supporting that. I think that, okay, you can do it for MySQL, for example, because in that case, you can do it in transaction, but yeah, most brokers doesn't support that. So you need to do it in this way that just separately, yeah. So, and we wanted to, create the interface of Watermill that will not kind of try to fool you that it can publish multiple messages at once, because, well, it's not possible by design. So this is the idea.
Perfect. Okay. Fantastic. At the end of the question so far.
Cool. Okay. And yeah. So as I said, so I think it's pretty hard to cover everything in, I don't know if it was 25 minutes or something like this, but yeah, of course, it's not possible to just show everything. So of course, it's not enough to show Kafka or Google Cloud PubSub internals. It's not enough to cover at least once delivered the application, and it is not enough to show the securest component. But no worry, at the end of the presentation, I have a link that you can check, and it should guide you for all these internals that you can check by your own. We have also a nice Grafana dashboard if you would like to have. Oh, yeah, looks pretty cool. This is also in the documentation. And yeah, I would like to always also thank to all contributors, because without you, Watermill will be not the same Watermill that it is now. And yeah, as I said, so it may be a lot. So that's why I prepared you a link with all the things that I will show, I shown you, and I will also show now. So where should you start? So of course we have some nice documentation. I heard that, I don't know, I was writing that, not reading, but yeah, this is what I heard from people. So this is probably something that you check. We have kind of a lot of examples. So I think that it's also good if you would like to learn, for example. And yeah, I think that what is also interesting, so it's putting everything in some context of this event. So it also encourage you to checking our ebook that I mentioned at the beginning. So this ebook is actually on a bit different topic, but I think it's good to know that. And I know that some people are looking like DDD, CQRS. I mentioned CQRS a bit earlier, yeah, that, okay, don't do Java or C# from Golang or whatever. But I think that, we got this topic in a bit different way. I mean, we didn't just blindly took these patterns from other languages and put it to Golang, because it's not working. Yeah? So instead, we are kind of solving problems that we have with that and going really deep to this idea. So yeah, if you are working on some thing that we are naming here business application, so I will highly recommend you to check that. And yeah, we have over $30,000 so far, so pretty a lot. And if you don't know Go, it's also something super fresh that we actually created, and it's Go in one evening. So this is online training that you can check and learn Go from us. So it will be linked a bit later. And yeah, I think that it's one of the most interesting things that we did so far. So yeah, worth checking. And yeah, so this is the magic link that I said that I will give you. So you will find, I prepared it especially for you today. Really, it was not available here 1 hour ago, or maybe 2 hours ago. So yeah, I think you should find everything what you need. This is my Twitter handle. So I'm trying from time to time tweet about some cool things that I know. And yeah, I think that's all for today.
Perfect. Is it just before we finish? I don't know if there's any other questions. I'll give it 20 seconds or so if there's any other questions. I think there's been a few questions so far, but I didn't know if there's any more. So I'll just give it sort of 10 more seconds and see if there's any questions from the audience. No, there doesn't appear to be anymore. So first and foremost, I'd like to thank you, Robert. Yeah, great presentation. Always fascinates me watching live coding. Yeah, which was great to see, and I'm sure people, the audience, learn a lot about Watermill, etc. And its its functionalities. Secondly, thanks to everyone for joining tonight. Obviously, great turnout as always, and it's all been recorded and will be shared on our YouTube channel. Finally, obviously, we carry out these events regularly on different topics within Golang, so please feel free to follow Amicus Recruitment on LinkedIn, etc. And stay in touch for all our events moving forward. But yeah, just finally, once again, Robert, thanks so much for the great talk this evening. I'm getting a few messages already, people saying they're going to try out Watermill, which is fantastic.
Well, thank you for inviting me. So yeah, it was cool to share some knowledge with you.
Perfect. Yeah, thanks again. And have a I'll just end the webinar, but have a great evening, everyone, wherever you are in the world and stuff like that. And we'll hopefully catch up with you all soon.
Yeah, thank you. Bye. Cheers.
Cheers. See you later. Bye.